Hello, this is Mr. Best. Welcome to Chapter 3, homework questions 41 through 46. Question 41, solve for the missing links in the sets of similar figures below. So on part A, it tells you that triangle ABC is similar to triangle OPQ. So remember, angle A matches up with angle O. So these two are congruent. B matches up with angle P. So those are congruent angles. And then C matches up with Q. And even though it looks like a right angle, I'm not going to assume it is. So I'm just going to make 3 marks indicating that C and Q are congruent as well. So keep that in mind. When you're given that similarity statement, it's telling you what things are corresponding. Same thing with the sides. Side AB corresponds to side OP. So AB corresponds with OP. Now they're not congruent, so I'm not going to write it that way. But those are the sides that you're looking at there. Okay. So now let's go through and actually answer the question. So we want to solve for the missing links in each of these. So right now it's asking for F, so side OQ. So let's set up our proportion. We have side BC matching up with PQ. So we'll do BC over PQ, and that will be equal to, and we're doing BC, and then we want to go and match that up. We can do this side AC, and AC matches up with OQ, and that's that letter F. So I'm going to write it as OQ, but that's what we're looking for. So let's plug in what we know. So BC is 4, PQ is 6, AC is 6, and then OQ is the variable F. So then we can go ahead and solve. Multiply both sides of the equations by 6F so that it cancels the denominator. And so the 6 cancel, that leaves us with 4F is equal to, and the F's cancel here, gives you F divided by F is 1. 6 times 6 is 36. Divide by 4, and F is equal to 9. And so if we look at this, 4 over 6 should be equal to 6 over 9. And both of those represent the same ratio of 2/3. All right, on part B, so once again it gives the similarity statement there, and side EF matches up with ST, so that will be 24 over 20 is equal to, and we're looking for this one over here, so GH, which we're going to use the variable G, and GH matches up with UV, and UV is the 15. Now when they give you more sides of the figure, you might have a little bit more issue in terms of matching those up, and that's why I'm showing you kind of what I'm looking at there. I'm going to go ahead and reduce the fraction 24 over 20 by a factor of 4, so that'd be 6 over 5, just to make the numbers a little bit smaller. And then now I can multiply both sides by 15. And when I do that, that will solve for G. So these are just going to cancel. And G is equal to, that would be 18. Okay. And then part C, we have MJ. So M and J right here matches up with Z and W. So that's right here. So 7 over H is equal to ML. ML matches up with YZ, or ZY, and so we have 3 over 10. And so on this one, I'm going to multiply both sides by 10H. So H divided by H is 1, so 10 times 7 is 70. 10 divided by 10 is 1. 3 times H is 3H. Divide by 3, and H is equal to 70 over 3 for the exact answer there. Question 42. In recent lessons, you have learned that similar triangles have equal corresponding angles. Is it possible to have equal corresponding angles when the triangles do not appear to match? What if you are not given all 3 angle measures? Consider the 2 cases below. Part A. Find the measure of the third angle in the first pair of triangles below. Compare the 2 triangles. What do you notice? Well, we can use the triangle angle sum theorem because we know that each of the angles have to add up, the sum of the angles have to add up to 180. So for the first triangle, we have 38 degrees plus 63 degrees plus, and I'll just call this x since it's not labeled, x degrees should equal 180 degrees. So 38 plus 63 would be 101 plus x is equal to 180 degrees. Subtract 101 and we get x is equal to 79 degrees. Alright, then if we look at the other triangle, we have 38 plus 79 plus, we'll call this one y, is equal to 180. Once again, triangle angle sum theorem. And on this one, we got 79 plus 38. So what's that, 117? And then take 117 or 180 and subtract 117. And that will be 63 degrees. So part A, find the measure of the third angle in the first pair of triangles below, which we did. Compare the two angles. What do you, compare the two triangles, what do you notice? We notice that the triangles are congruent. You have the same measures for each of them, and that the corresponding angles are equal. And so once again, corresponding angles, this angle corresponds to this one. Those are congruent. The 79 corresponds to that one, which is 79, and then the 38 corresponds to this one. Part B, examine the second pair of triangles below. Without calculating, do you know that the unmarked angles must be equal? Why or why not? Now this one's a little different than the one above. What you'll notice is that 46 degrees is equal to 46 degrees. 73 is equal to 73. So based on what we did above, if we take 180 or 46 plus 73 equals 180, that's plus the angle that's missing is equal to 180, then those two equations are going to be exactly the same, which means this third angle will also be equal in both of the triangles. So without calculating, could we recognize that the unmarked angle must be equal? Yes, and that's once again looking at the triangle angle sum theorem, knowing that if we have two angles, if you add those up and subtract 180, take 180 minus those two angles, then the third angle is going to be the same. Question 43. Frank and Alice are penguins. At birth, Frank's beak was 1.95 inches, while Alice's was 1.50 inches long. Frank's beak grows by 0.25 inches per year, and Alice's grows by 0.40 inches per year. Write an equation to represent the length of each penguin's beak in X years. Alright, so part A, let's start with Frank. So we know Frank initially has a 1.95 inch beak when born and grows at 1.25 inches per year. So you're given the initial and the growth rate. So we will say y equals, it does tell us to use x for years, and since it's growing at 0.25 per year, you got 0.25 times x plus what it started at, which was 1.95. Now for Alice, we have Alice starts at 1.50 inches long, so that's the initial, but hers grows at a quicker pace of 0.40 inches per year. So y is equal to 0.40x plus the initial of 1.50. Part B, how old will they be when their beaks are the same length? So how old will they be when their beaks are the same length? So since we're looking at the same length of their beaks, which represents the y value, we can set those equal to each other. And we get 0.25x plus 1.95. When is that equal to 0.40x plus 1.50? So we can subtract the 1.5 to this side, and then I'll subtract the 0.25 to 0.25x, sorry, to the other side. So kind of doing two things here at once. This will leave me with 4.5, or 0, I'm sorry, get my decimal in the right place here. 0.45 is equal to, and this is a minus, so that's 0.15x. And then we can divide by 0.15, and x will be equal to 3. So how old will the penguins be when their beaks will be about the same length? And that will be 3 years old. Question 44, rewrite the statements below into conditional if-then form. The area of a rectangle with base x and height 2x is 2x squared. So we're going to write this as a conditional. If a rectangle has a base x and a height of 2x, then the area is 2x squared. All right, part B, the perimeter of a rectangle with base x and height 3y is 2x plus 6y. So this is the perimeter. If the base is x and the height is 3y, if you find the perimeter is 2x plus 6y. So to write as a conditional statement, if a rectangle has a base x and a height of 3y, then the perimeter is 2x plus 3y. And the last one, part C, a rectangle with base 2 feet and a height 3 feet has an area of 864 inches. Now pay attention to that. One is in feet and the other one is in inches. So on this one, if a rectangle has a base of 2 feet and a height of 3 feet, then the area is 864 square inches. All right, and then that finishes the conditional statements for those three. Question 45. Misty is building a triangular planting bed. 2 of the sides have lengths of 8 feet and 5 feet. What are the possible lengths for the third side? So just to kind of help us with the visual here. So if we have a triangular planting bed, it can be all sorts of different things. What we do know, though, is 2 of the sides. One of those is 8 feet, and the other one is 5 feet. What can the third side be? So remember going back to the lesson on kind of opening up this angle right here as far as you possibly can. So think about making this 5 feet and then opening up this side with 8 feet. That would give you a total distance of 13 feet. Now that doesn't create a triangle, so it has to be less than that. And then the other thing we did is we took this angle and we closed it up. So once again, you might have 8 feet this way, but then we would take this angle right here and move it as close to this as possible. So then kind of pretending that we lay it flat, and this would be our 5 feet. So we'd have to open it up just a little bit, but the difference between these two, 8 and 5, is 3 feet. So it has to be a little bit more than 3 feet, but it has to be less than 13. So how can we write that? We can say that this represents x. So we want x to be less than 13, but greater than 3. So this is how you can describe and make sure you're listing all the possible lengths of the third side. So obviously those are the possibilities. Now to make an actual planting bed with some of those dimensions, such as 4, might not make a whole lot of sense. But in theory, those are the possible lengths of the third side. Question 46, plot A, B, C, D formed with the points on there onto the graph paper. So let's go ahead and start there first. All right, now that we have plotted the points and connected them, use the method from problem 3-2 to enlarge it from the origin by a factor of 2. Label this new shape A prime, B prime, C prime, D prime, and E prime. So you might need to go back to 3-2, but what we did, if we were enlarging it from the origin, we kind of looked at our slope triangle. So let's say for, I guess we'll start with A, and we go down to the left 3. If we're going to enlarge it by a factor of 2, that would be a factor of 1. We would do it again, down to the left 3. So this would represent A prime. For B, we go down 2 and to the right 5. So we go down 2 and to the right 5 again. That would be B prime. C, we're going to the right 5. or I guess it doesn't matter, but we can go up 3 into the right 5. So we'll go up 3 into the right 5 again, and there's C prime. For D, we're going up 6 and over 1. If we went up 6 again and over 1, that one's going to be off my grid paper, but that would be what appears to be a 212. And then the last one on E, so we're going up 3 into the left 3. So if we go up 3 into the left 3 again, this would be E prime. And once again, I got to make sure we're clear that the factor is 2. That's why we're only doing this twice. The first one is to the original figure, and then the second one we've now enlarged it by a factor of 2. So let's go ahead and graph this. And so we've enlarged it from the origin by a factor of 2, and then we did label the new shape as well. Now in part B, find the area and the perimeter of both figures. So we'll start with the perimeter of the original. And the perimeter of the original you can count, since it's a vertical line, that's 5 units. From A to B, it's like 8 units. And then B to C is 5. And then on C to D and D to E, you're going to have to create a right triangle, and this is a 3, 4. And when you do Pythagorean theorems, it'll make this length 5. And then this one's the same because it's 4 this way also. So this will also be a 5. So 2 more 5s to add on. So that looks like we're looking at 28 units for the perimeter of the original. We'll then do, let's see, find the area and the perimeter of both figures. So let's go ahead and do the area of the original. The area, we can break it up into 2 parts. We can do this rectangle, and then we can do the bigger triangle. So the rectangle is a 5 by 8. So 5 by 8, but then we want to add the area of the triangle. We can do a base of 8, and then we know the height right here is 3. So it looks like we're going to get 40 plus 12. So we have the area of the original equal to 52 units squared. All right, let's go and find the perimeter of the new figure. So now, instead of 8, now your base, you can count all those up, but that's going to be 16, because we know that because, once again, the factor is 2, so 16. So each of these is just going to get doubled. So I can go back up to my original perimeter. I guess I should put them in order. Maybe that might help. So 5 now becomes 10, 8 becomes 16, and then these also become 10 for each of these. So if we add that up, 40 looks like 56 units. So it went from 28 to 56, and once again, think about your factor of 2, so your perimeter increased by a factor of 2 also. Your area of the new is, once again, you can break this up into this rectangle and triangle. So this length here was 16, this one was 10. So we have 16 times 10 plus the area of the triangle, and this height right here was 3, so it doubles to become 6. We also have the base of 16 times the height of 6. So what do we get here? 160 plus half of 16 is 8. 8 times 6 is 48. So it looks like 208 units squared for the area of the new. Now you can see the area of the original 52. You don't just double it or times it by a factor of 2 to get the area. It actually gets multiplied by 4. So we've done that a couple different times now in the homework and in class as well.